So, if you take a pair of shears to a blue porterweed and you just sever it down to a single isolated node and then bury that tiny fragment in the dirt, I mean, realistically, it shouldn't survive.
Right. It really shouldn't.
Yeah, because you've essentially stripped away its entire root system. You've taken its energy reserves, its structural support, everything.
You've left it with nothing.
Exactly. Yet, not only did this tiny little cutting survive, but a software developer named Ang actually spent hundreds of days meticulously logging exactly how it reprogrammed its own biology to pull off that survival.
Which is just an incredible collision of two seemingly incompatible worlds, you know?
Yeah.
On one hand, you have the messy, chaotic, deeply analog world of a garden. Variables are infinite there, and, well, failure is usually pretty quiet.
Right.
And then on the other hand, you have the hyperlogical, deeply rigorous mind of an open source programmer.
Yeah.
Someone who builds systems where a single misplaced semicolon basically brings the whole architecture crashing down.
It's wild. And that exact intersection is the entire focus of today's source material. We are taking a deep dive into a journal entry from a blog called keymm.org.
Great blog, by the way.
Oh, it's fascinating. The author, Ang, refers to himself as an old software plumber. He's someone who spends his nights tinkering with free, Libre, and open source software, often called flawless.
Right, floss.
But the specific post we are looking at from March 2026, it isn't a coding tutorial at all. It's titled Notes on Gardening Part 844.
And, I mean, the fact that it is part 844 should immediately signal the level of obsession and, documentation we're dealing with here.
Oh, completely. It is a staggering archive. But our mission for this deep dive is to isolate just one hyper-specific micro-experiment from that massive journal. We are going to examine Ang's attempt to propagate that blue porterweed from a single node. And along the way, we'll decode the hidden cellular mechanisms of plant growth, uncover the frankly frustrating patience required to build a taproot system, and ultimately explore how applying a programmer's version control mindset to your own life can radically change the way you learn and build and just observe the world.
I love that.
Okay, let's unpack this, starting with the sheer audacity of Ang's cutting technique. Because it's not normal.
No, not at all. To really appreciate the risk Ang is taking here, we have to look at the standard methodology for propagating plants. Like, when you want to clone a plant, you typically take a long stem cutting that includes several nodes.
Right.
And that length, it provides a massive biological safety net. A longer stem holds way more stored carbohydrates.
So it's like a battery.
Exactly like a battery. It gives the cutting a runway of energy to survive the trauma of amputation, basically, while it frantically tries to generate new roots.
But Ang just throws that safety net completely out the window.
He really does.
He bypasses the standard multi-node stem and experiments with just a single short node.
It is a brutal minimalist approach. I mean, by isolating a single node, you are stripping away almost all of that stored energy we just talked about.
Yeah.
The margin for error drops to absolute zero. If the moisture isn't perfectly dialed in, or, if the temperature fluctuates even a little too much, that cutting is dead in a matter of hours.
Wow. It actually reminds me of stripping down a massive software application, like taking a hugely bloated legacy code base and just deleting everything until you're left with one single line of code just to see if it can rebuild the entire operating system.
We'll have to stop you right there.
Oh, yeah.
Yeah, because a single line of code doesn't actually have the architectural capacity to execute anything on its own, let alone rebuild an entire system.
Oh, fair point.
A much more accurate analogy, especially given Ang's background, would be isolating a single microservice. Or, say, deploying a containerized application, like a Docker container.
Ah, okay, I see. Because a Docker container has all the core logic and the dependencies kind of wrapped up into one isolated package.
Precisely. It lacks the surrounding bloated infrastructure of the main application, right? But it contains its own bootstrap logic.
Okay, that makes sense.
And in botany, this is actually known as cell dependency.
Dependency.
Yeah. The cells inside that single plant node are essentially biological stem cells. They are undifferentiated meristematic tissue.
Meaning they can become anything.
Exactly. They contain the complete genetic instruction manual required to rebuild every single part of the plant, from the deepest root to the highest leaf. They just need the right environmental triggers to actually execute that code.
Man, that makes so much more sense. So the node is a self-executing container.
Yes.
And Ang is basically watching the external interface to see if that internal code is compiling, because he specifically notes in his journal that he hasn't dug the plant up yet. But because the leaves on this tiny cutting are maintaining a lush green appearance, he assumes the roots have successfully sprouted beneath the soil.
Which is just a brilliant piece of deductive observation on his part.
Yeah.
He is reading the outputs to verify the unseen inputs. If those leaves are staying green, it means they are maintaining osmotic pressure.
Yeah.
Water is actively being pulled up into the plant tissue.
Right, and since the stem was cut off.
Exactly. The only biological mechanism capable of generating that kind of vascular pressure is a functioning, newly established root system.
So he trusts the front-end display, the green leaves, to confirm the back-end database is actually connected.
That's a great way to put it.
But Aang isn't content just assuming, right? Eventually, he does dig beneath the soil to audit that back end. He checks the roots. And the visual proof above ground leads to a massive biological mystery below ground.
Oh, yeah.
Because what he finds completely defies standard botanical expectations for a cutting like this.
It really does. Because in almost all cases, when a severed stem somehow manages to survive and push out new growth, it develops fibrous adventitious roots.
Okay, what are those exactly?
These are roots that generate rapidly and honestly somewhat randomly from the wound tissue of the cut stem. They form this dense, chaotic, hairy net that spreads outward horizontally, just right below the surface of the soil.
Okay, but here's where it gets really interesting. Because Aang digs up the single node, and he does not find a chaotic net.
No, he doesn't.
He finds one solitary, incredibly thick root shooting straight down into the earth.
A primary taproot, which, is an extraordinary biological pivot for a cutting to make.
Can you break the anatomy of this down? Because Aang outlines the specific tiered structure of what this plant is doing underground, and it sounds like it's built like a skyscraper.
Yeah. What's fascinating here is the deliberate phased architecture of this root system. It is heavily staggered. The source notes that the plant follows a really strict protocol.
Okay.
Phase 1 is the development of that primary taproot. Its sole function is to act as a deep structural anchor, just driving vertically into the subsoil.
So it's literally just a single spike plunging downward.
Just one spike, driven entirely by gravity and localized hormones.
Wow.
Then comes phase 2. Only after that primary taproot is securely anchored do the secondary or lateral roots begin to branch out.
Okay, so they wait.
They absolutely wait, and then they grow horizontally from the main spike. These provide lateral stability against wind, and they begin the broader work of nutrient absorption.
Got it.
And finally, phase 3 kicks in. Tertiary roots sprout from the secondary roots, creating this complex, really fine-tuned network for gathering micronutrients.
Okay, wait. I have to push back on this strategy.
Sure.
Because from an evolutionary standpoint, it seems incredibly reckless to me.
How so?
Well, if I am a tiny single node cutting, I have almost zero stored energy. I'm in a state of biological panic, right?
Right.
So why would I expend my severely limited cellular resources driving one massive anchor deep into the dark where there is very little immediate moisture? Why not instantly build that shallow fibrous net across the surface to hoard every single drop of morning dew or light rain as fast as possible?
That's a really good question. You're touching on a classic biological trade-off here between short-term resource acquisition and long-term resilience.
Okay.
A fibrous root system is fantastic for a quick grab of surface water. But surface water evaporates rapidly.
Right.
If a drought hits or if a really strong storm rolls through, a shallow-rooted plant is the absolute first to die or just get ripped right out of the ground.
Ah, so the plant is hedging its bets against a future crisis.
Exactly. It is playing the long game. And this makes perfect sense when you consider the specific plant Aang is working with here.
The Blue Porterweed.
Right. The Blue Porterweed, or Stachytarphet cayennensis, is essentially a tough tropical weed. It evolved in environments where dry spells are super common and competition for surface water is fierce.
Oh, wow.
Yeah, so by funneling all its initial energy into a taproot, it sacrifices rapid, immediate expansion to secure access to deep, stable moisture reserves that its competitors just can't reach. It is prioritizing structural permanence over quick gains.
Man, the cellular intelligence required to make that kind of resource allocation is just wild.
It really is.
And that biological reality leads directly to the next dilemma Aang faces in his journal, which is the excruciating timeline of this process. Because driving a heavy anchor into the bedrock like that, it takes a massive amount of time.
It's so slow. Aang specifically highlights the need for restraint here. The visible progress is agonizingly slow. For weeks, You might see absolutely zero new leaves or upward growth.
Nothing at all.
Nothing, because 100% of the plant's biological compiling power is focused underground on that single downward spike.
And I mean, as a gardener, your first instinct is usually to, like, quote unquote, help the plant, right?
Yeah.
You want to give it fertilizer to speed things up.
Oh, absolutely.
But Ang notes that applying fertilizer too early is a fatal error.
It's the worst thing you could do.
Right. He waits. He just observes. And only after he confirms that the primary taproot has successfully anchored does he introduce fertilizer, and he does it specifically to trigger the lateral, secondary, and tertiary roots.
The timing is everything. If
Yeah.
you dump nitrogen-heavy fertilizer onto a plant that is still trying to establish its primary anchor, you will literally chemically burn the delicate wound tissue.
Ouch.
Yeah, or you'll force the plant to push out weak, leggy top growth before it actually has the structural foundation to support it. The plant will just collapse under its own artificially induced weight.
So you have to let the architecture set.
You have to.
Yeah.
And if we connect this to the bigger picture, this is a profound analog for how humans acquire foundational knowledge.
Ooh, I like this.
Think about tackling a deeply complex subject. Maybe you're learning a new coding language like Rust or, I don't know, trying to understand advanced macroeconomic theory.
Sure.
In those early stages, you spend weeks or months just reading syntax or learning basic definitions, and it feels like you are going nowhere. You have nothing impressive to show for your effort.
No green leaves.
Exactly. No green leaves.
You feel completely stagnant. You watch other people seemingly rapidly expanding their fibrous networks of superficial knowledge, just throwing out buzzwords, and you're just stuck in the mud.
But you aren't stagnant at all. You are driving a taproot. You are doing the invisible heavy lifting of building a structural framework.
Wow, yeah.
If you try to force advanced applications too early, like if you try to build a complex application before you actually understand the core logic, you crash. But if you have the discipline to just sit in that slow, invisible phase, letting the foundation anchor deep into your brain, then eventually you hit a tipping point.
And that's when you apply the fertilizer.
Yes.
Yep.
You introduce a new project or a catalyst, and suddenly your lateral understanding just explodes outward. You can connect concepts rapidly because the central anchor is already holding you steady.
That is so true. I mean, think about the projects you are working on in your own career or personal life right now. Are there areas where you feel deeply frustrated by a lack of visible progress? Are you beating yourself up because you expect a quick fibrous spread of immediate results, when in reality the task requires the slow, unglamorous work of building a taproot?
It's hard to accept.
It is. Sometimes the absence of rapid surface growth isn't a failure of the system at all. It is just the necessary architecture of deep anchoring.
It requires a massive psychological shift to be comfortable with that kind of invisible progress. Most people abandon the project right before the anchor sets.
Yep.
Which really brings us to the mindset required to actually pull this off.
Yeah, because to fully appreciate the meticulous, unbothered patience Ang shows toward a single root system, we have to look at the massive scope of what he is building over at kianmeng.org.
Oh, the scale is unbelievable.
It is. When you look at the sidebar of his site, the sheer volume of tracked data is staggering.
It is an exercise in relentless empiricism.
We mentioned earlier that this particular post is gardening part 844.
Right.
But right next to it, the journal logs continue into completely different domains. There are notes on fish keeping up to part 216.
Wow.
He tracks notes on Haskell programming at part 90. He maintains concurrent, highly detailed logs on dieting, Go programming, Rust, artificial intelligence, and photography.
It's like a full-time job.
And this archive stretches all the way back to 2011, just month after month, year after year.
The discipline required to maintain that level of documentation for over a decade is incredibly rare. He is essentially treating his entire life as a giant open source project.
So what does this all mean? Why does a software developer, someone steeped in the digital abstractions of floss, apply this exact same hyper-rigid framework to something as tactile and messy as watering a blue porterweed?
Well, this raises an important question about how our professional frameworks fundamentally alter our perception of reality. Let's look at the tools Ang uses in his day job.
Yeah.
If you are building complex software in languages like Elixir or Python, you rely heavily on version control systems like Git.
Right. And for those who might not be in the software world, version control is essentially a time machine for your code, right?
Exactly.
It tracks every single keystroke and change you make across a massive project.
It's a way of isolating variables.
Yeah.
In software, if a new feature breaks the application, you don't just sit there and guess what went wrong. You look at the commit history.
Yeah, you roll it back.
Right, you roll back to the exact line of code where the error was introduced. You create separate quote-unquote branches to test new ideas without ruining the main project. And Ang is taking that exact same methodology and laying it directly over his garden.
Oh man, he is treating every single plant cutting as an isolated branch of code.
Precisely. Nature's chaotic, right? It doesn't give you error logs when a plant dies.
Yeah.
It just wilts.
Right, it just dies.
But Ang forces order onto that chaos through relentless documentation. By tracking this specific cutting as part 844, he is logging the precise inputs. Input A, a single short node. Input B, specific moisture levels. Input C, delayed fertilization.
And then he logs the output, which is a primary taproot.
Yeah.
And because he documented it so rigorously, the result is reproducible. If the cutting had rotted, he wouldn't just throw his hands up and say, well, I guess I don't have a green thumb.
No, not at all.
He would look at the journal, isolate the variable that caused the rot, like maybe the soil was too damp, adjust that one single variable, and run the compile process again in part 845.
He completely removes the mysticism from the hobby.
Yeah.
We so often treat gardening, or really any complex analog skill, as a talent you are simply born with. But Ang proves that it is just a system of variables. His floss background teaches him that knowledge shouldn't be hoarded. It should be documented, tagged, and shared publicly so the next person doesn't have to make the exact same mistakes.
It changes the entire outcome of the garden. He isn't just randomly sticking plants in the dirt and hoping for the best.
No?
He is building an empirical database of biological behavior. It's honestly so empowering. You realize you don't need innate talent to master a complex system. You just need version control and the willingness to run micro-experiments.
And notice how this structure doesn't drain the joy out of the process for him either.
Right.
The rigor actually enhances the beauty.
Uh-huh.
Because he is paying attention with the exactitude of a programmer hunting for a bug, he notices the profound architectural difference between a fibrous root and a taproot. A casual observer would just look at it and see dirt.
Just a root and some dirt.
Exactly. But Ang sees an evolutionary strategy unfolding in real time.
It is a masterclass in how to move through the world with intentionality. So to bring all these threads together, today we started with a tiny, severely isolated single node of a blue porterweed. We looked past the lush green leaves on the surface to discover the hidden, deliberately agonizing timeline of the taproot system.
A true biological masterclass in prioritizing deep structural anchors over shallow, rapid expansion.
Yeah. And zooming out, we saw how applying a programmer's version-controlled open-source mindset to everyday observation can strip away the chaos of the natural world and reveal the really elegant systems running underneath it all.
It proves that the most powerful tool you can bring to any complex environment isn't prior expertise. It's just a willingness to observe, log, and isolate your variables.
Absolutely. And that leaves us with one final thought to mull over as you step back into your own life. We've seen how an incredibly complex, resilient living system can be entirely bootstrapped from a single, carefully isolated node, provided it is given the time to drive its anchor deep.
Right.
So I want to ask you, what is the single node, the foundational idea, the core habit, or maybe the central relationship in your own life right now? If you stripped away all the bloated infrastructure and just gave that one node the patience and the deliberate focus it needs to build a taproot, what kind of entirely new system could it grow into?